we go. All right. Hi, I'm a developer advocate at LaunchDarkly. We do feature flags as a service, and I get to say that because they paid for me to get here. So that's all that we're going to do for that. I am here to talk to you about scars. And it's great that I get to speak after Maddie because he talked about organizational trauma. And I'm going to talk about some organizational trauma and some sort of productive things that we've done around it. So I have a keloid scar right here from when I was like 11 and I was trying to cut a piece of ham with a plastic knife and I managed to wound myself severely, which is embarrassing, but not as embarrassing as the one that I have here, which I got from literally running with scissors when I was 15, because I make good choices. So the thing is, we all have scars. We all have these experiences that are written on their skin. And it's sort of an interesting trope that when we're talking to each other at DevOps Days, one of the most popular types of open spaces is basically just get together and tell each other our traumatic stories. Like war stories are super popular. Oh, this one time my server caught on fire and then sank into a swamp. You would totally go to that open space. You know you would. So when we talk about organizational trauma and scars, we find it both sort of satisfying to see that other people have suffered the same way that we have, and cautionary in that we're like, well, I don't want to end up like that. Organizational scars are things that cause organizations to under or overreact, just like what Maddie was saying. We are always remembering what happened first. So one of the examples of this is the American weather system used to, until 2016, send out things that were teletype. And they were 100% capitals, and there was no punctuation except periods. So it always felt like the weather was yelling at you. It would be like, today is a perfectly nice day. It is 20 degrees Celsius, sunny. You're like, okay, I maybe didn't need to be yelled at about that. It would use the same sort of tone for, there is a hurricane coming and you will all die. Except they didn't then say, you will all die. In 2016, we updated a lot of things and we added actually stronger language for, seriously, you need to get out of there. And we also added like the exciting innovation of lowercase letters. It was pretty amazing. So why did that change? Well, we had been operating up until 2016 on machines that could only send capital letters and periods. And they were everywhere, and they were ubiquitous, and that's just how it worked. But it turns out that we have some better technology now, and we upgraded a little bit. Why do Americans use inches and pounds? All American second graders go through this thing where we learn about the metric system. And then we get really angry because it turns out that there is a logical way to measure things, and it involves like 10, and like you can multiply things out and you can predict what size something is. And we're like, what is this 12 inches to the foot, 16 ounces to the pound? This is crap. I want the metric system. Because in second grade, you're not deeply attached to either one, and you're like, I would like that one, thank you. That seems much better. Well, there's a reason that we're still using it. It's because it would be so expensive to change it. So expensive, so cripplingly expensive. Everyone who works on cars in the US has two sets of sockets, the metric and the US. And sometimes they're in like 13/16 of an inch, and sometimes they're in like centimeters and millimeters. And we're just like, oh, okay, I don't know which part of my car I'm going to need which one for, so everybody has both. Yeah, that's pretty dumb. But when NASA did a study to see how much it would cost them to convert entirely to metric, the answer was $46 billion. And they're like, that's too expensive. I would argue that it depends on how many Mars rovers you mean to crash because of a measurement incompatibility. But I'm not in charge of NASA. So the reason that we're not doing this is because we know it would be so expensive and painful. And we have all of these generations of people who, like me, are like, so what you're saying is 0 is freezing. Say it again real slow. I always like it when I travel in the winter. People are like, oh, what's the weather back home? And I'm like, oh, it's like 20 below zero. And they're like, oh, that's pretty cold. And I'm like, Fahrenheit. And they're like, this may not impress people from Copenhagen. So why do we use checklist? Who here has read the Checklist Manifesto? A few of you. You should go read the Checklist Manifesto. It's a great book. It's pretty short. And it's basically why surgeons have stopped leaving things inside our bodies. Because they have a checklist of everything that goes in and everything that comes out. And if you've ever flown on a plane, you are still alive thanks to checklists, because pilots have an enormous set of checklists that they run through every condition, including we're about to take off and have we set all of the flaps and wings and everything correctly. Checklists are pretty amazing. They are a codified representation of things that we have already screwed up. When I was a tech writer doing print production, I had a checklist 58 items long. Because every time I sent something to the printers, which cost real money, I would miss something. I would miss the crop marks, I would miss the color register, I would miss a way to change the fonts so that they were more printer friendly. So every time my boss yelled at me, I added something to my checklist. And finally, I showed him my checklist. I'm like, this is what it takes to get something out to print production. And he's like, wow, that's a lot of steps. I'm like, it is. Huh, you noticed. So we use checklists as a way to react to the scars we have. Because not only do scars carry the story with us, they also sometimes limit mobility and they limit movement. If you've ever, say, had a bike accident where you got road rash, gravel on your knees and your elbows and your face, and they had to pick gravel out of you because you were on a bike and you were doing, I figured this out, 45 kilometers an hour, because did I mention bad life choices? You'll know that you can't move freely while you still have these scars healing and generating. So when I think about checklists, I think about scar tissue that keeps us from repeating the same mistakes. So this is my checklist for traveling. And every one of these items I have forgotten at least once. And the bullet at the bottom is for the next thing that I forget. Yeah. Toothbrush is the least drastic of these. But passport is a thing that happened once, and that was suboptimal. Our scars are a story, and our organizational scars are a story. But sometimes you don't know the story that goes with the scars. You just know, oh, we don't do it that way. Oh, well, we have a staging server. Staging servers are a scar. They are an evidence that we have been traumatized by pushing directly to production. It's not necessarily a bad scar. There may be good reasons for not pushing directly to production. But when you think about it, staging is a way to say, I am scared. I have been scarred. I am worried about how this is going to work out, so I'm going to do like a halfway thing. Not the whole thing. Because institutions are always reacting to the last thing. It's really difficult to get somebody to be excited about doing something that has already failed, right? So when you're working with an organization and somebody's like, oh yeah, no, we tried Go, but it didn't work. What that actually means is we tried Go, and there was this one person who wouldn't work with it, and we had a lot of fights and we gave up, right? Whatever it is, people are always reacting to the last thing, but they won't tell you what the last thing was because they haven't thought of it as a scar. They've thought of it as a best practice. And the difference between a scar and a best practice is it's pretty fuzzy. Like, best practices are things that we learned the hard way, but they may also not be adaptive for the world that we're in now. So now we're going to talk about code history, which I think is a super fun part of this talk, and this is where this talk actually started, because I'm like, how is it we ended up where we are? There are 3 linked parts of every, I sort of call them a code era. And they are the development method that you're using, the version control method that you're using, and how you're deploying. And when one of these things changes, the others change too. So let me show you how this works. When I was 8, my dad got a CP/M-based PC. Because my dad, I love my dad. My dad is an optimist. He's an early adopter with really bad guessing abilities. He also Betamax, Laserdisc, CD cassette, mini disc. Like, if there is a bad choice that you could make when technology forks, my dad has made it. But he remains perpetually optimistic. It's very charming. So he got us this computer, and the way that you program games in this computer is that you type them in BASIC. So that was my first programming language, and I can't say I knew what I was doing. I was copying things from a magazine to make like this great Christmas stocking animation. It was amazing. It's all ASCII art. But the thing is, that's how you transmitted code. It was printed in a magazine, and you typed it in with your own little fingers, and then like 200 lines later, it didn't work. And if you were 8 years old, you didn't know any good bad words. You're like, if I knew any bad words, I would say them right now. But I don't. Fudge. And then you had to go back and look with your own little eyeballs to see where you'd made a code mistake, because that was all we had. So what we have here is hand-typed code, physical backups, right? And when we released it on punch cards and printed material, because programs were ephemeral in the computer. Once you turned the computer off, they were gone, right? You remember this? If you knew somebody super fancy, they maybe had a disk drive. As rich people had disk drives. All right, so time moves on, and we're doing waterfall development. And we're at a DevOps Days, and so we have this instinct of, why would you do waterfall? It's so slow and cumbersome and awkward to do. And shared code and IDEs. Well, I'll tell you what, waterfall is a lot better than your code just vanishing every time you turn your computer off. It's kind of amazing. But if you're working together on a shared code base, you have this problem where you want to make a change at the same place somebody else wants to make a change, and you can't both do it at the same time. So what we had was lockouts. This is like SVN. Basically what happened is you checked out a file, and you made your changes in it, and you checked it back in. It's not a merge, because nobody's like accepting or rejecting these changes. It's just checked back in. That's what it is now. And this kept us from stepping on each other's code, and that was really important because it was super awkward when we did that. But it also meant that if like somebody got sick and they had a file checked out, you just couldn't work on that part of the program. Or you could break the lock, but lock breaking was awkward and worrisome, and you could sometimes break the file when you broke the lock. So who here remembers doing waterfall? Anybody older? Yes, excellent. Right? So do you remember how source control worked? Right? You checked things out, and you just checked them back in at the end of the day, unless your boss was nicer than mine. And when we released to Gold Master. We released to disk. And here's the thing about that. When you ship, you're done. You're done. There is no way to update. When we were doing this mostly, there was no the internet. Software didn't come that way. Even though we did have some minor layer of connection in, say, like the late 90s, we didn't push software through it. We could only barely push like cat GIFs through it. We didn't really even have good GIFs. It was dark times, people. So when you release software, if you had screwed something up in QA, that's just the way it was. It was broken. The best thing that you could do, well, that's not optimal. Stop that. The best thing that you could do is ship a disk to do an update, which is why Y2K was super exciting, because we didn't really have the ability to update a lot of that software that was running. Who here has ever used this? Yeah. It was great when it came out. Don't make that face, Kit. It was so much better. It was amazing because it had a word processor and a spreadsheet function and like the ability to make very large banners all in the same software. And it was like 26 disks. and the box was like this big. You had to have a team working together to do Waterfall, to do a big release that big. And it took you 2 to 5 years. You're like, okay, the reason we have Waterfall is because if everything isn't done by the time we release, we're never getting it in. That's all we've got. It's a really different way to the way we think about software now. All right, so moving along, we now have enough internet to be able to do code. We've adopted some of the lean things. I started working in technology in 1999, which places me precisely right before Agile when we were still talking about extreme programming. So this is the thing that I came in. I'm like, okay, I'm going to be a technical writer. I'm going to sit on a beanbag chair and we're going to write user stories on index cards. This is how we did it. And the user story was constrained, like this is how you do it, and then somebody would write a user story and they would turn it in. But this method works really poorly with how we were doing code with the checkouts. Like, it sucked, honestly. So Linus invents Git, which is great for a distributed team. It's great for people who are working on very small parts of the same code base. And instead of checking things out and blocking them so no one else can ever see them, you check things out, you sort of check out a copy, and you make your changes to it, and then you check it back in, and there's a consent-based process where people agree or disagree with your changes. Well, that's pretty radical. That's a lot different than how we were doing it before. And for the last 20 years, that's how we've been doing it. What's the first thing you do when you start to code? Spoiler. What's the first thing you do? Come on. Good morning. Git branch, right? The first thing you're going to do is make a branch because you don't want to be messing with the main code. And this is what we teach everybody who's going through school right now, is first make a branch. And there's only one problem with this. It turns out that there's a merge conflict. Because the minute you check something back in that somebody else is working on, they've made changes, you've made changes, they're mutually incompatible. The longer you've had it checked out, the more mutually incompatible it is. I would like to eliminate the job of release manager, because it's mostly toil. It's toil and it's settling arguments. I would like it to be something cooler. Like, release manager could be really awesome. There's a lot of things we could do with that title. But what we're using it for right now is like settling feuds. And that doesn't seem like a very rewarding job. Because what happens is people have made mutually incompatible changes, and somebody has to figure out how to cherry pick what they want in and how it's going to work and who doesn't get their work, acknowledged. And when we need to fix something, all we have to do is push it out. Because there are a lot of you who do actually, I've talked to several of you, have air-gapped systems where you cannot talk to the internet. But the vast majority of us are like, what? Software comes from the sky. Like, it just trickles down into our systems, and sometimes we don't even have to acknowledge it, which is its own scary, problematic thing. But it's the way we work right now. So when you're releasing, because you're releasing these small iterations, you release much faster. It's easier to send an update. It's easier to have a fight. All of these things are true. But I think that we are on the verge of something new. When we talk about microservices and mesh computing and functions as a service and serverless and all of the buzzwords that you're like, you would like to go back and tell your boss you heard her talk about it, what we're actually talking about is a fourth age of computing, a new way of doing things. I sort of think of it as the yours, mine, and ours model of computing, of software, because what we're doing is we're saying, I don't actually care who wrote this software. All I care about are the events or endpoints. I might have written it, you might have written it. As long as whatever is in that black box puts out something predictable, I don't care if you did write it in BASIC. Like, it doesn't matter to me. what we're doing is stitching together this functionality to make it more robust, more interoperable, more customizable. And the only way that works is if you're doing feature flags and trunk-based development. Not the only way, but mostly the only way. Because instead of having every time we make something new, we do a branch, we're going to keep all of our code in trunk, in main. Everything is in main. And you're like, well, I don't want to release broken code. I want you to release broken code. I don't want you to tell people that there's broken code. I want you to put it behind a feature flag so that no one else can see it. And I want you to push it out to production. Because how else are you going to test it except in production? We think that we're going to test in testing, and we do. We think that we're going to test in staging. Staging is a lie. Staging is a dirty lie. Who here has enough money to stand up a full replica of their production in staging? Last time I asked this, there was somebody from AWS. I'm like, you don't count. Because what we are doing in staging is this reenacting this scar, where we're like, if I push it to production, I might take production down. You're not going to take production down. Production is safe because you have a feature flag. You're only going to turn it on for you, or only for the IT group, or only for the beta users. And then you're going to find out if it is sturdy in production, with real data, with real latency, with real interoperability problems, because you don't know what other people's APIs are going to do, right? They've made a contract, but we've all been on the other side of that contract where we're like, I think I'm going to serve this. It's going to be fine. Nothing's going wrong. It's all good. So everybody is counting on each other to fulfill their contracts. But if you don't test in production, you're not testing those contracts. And that's really important. So this is really complicated. Whenever I talk about doing feature flags, I get a bunch of pushback about how do you test that? And my answer is actually in opposition to Aubrey's 100% test code coverage. I'm like, all you have to test is everything on, everything off, status quo, because if you're not testing status quo, you don't know what you broke, and with the new thing on. That covers the vast majority of your cases. There will be interactions, but if you're doing progressive rollout and progressive deployment, you're going to catch those edge cases before they become catastrophic. So when we're talking about how microservices can work together and how to do testing, one of the things that we need to do is figure out not how to test everything, because that's a false security. If you say I have 100% test coverage, what does that mean? It means that you have this symptom that you're covering. So when you go to the doctor doesn't ask you how your thyroid is doing. The doctor asks you about your energy levels and if your hair is falling out and if your skin is okay. And even then, they're like, oh, something may be wrong with your thyroid. They can't directly test the hundreds of hormones that your thyroid puts out. What they do is they test the thyroid stimulating hormone, which tells us whether your body thinks it needs more thyroid. We're doing the same thing. We're like, oh, I think that if I have 100% test coverage, 100% coverage, I'm going to be safe. But no, that's just a symptom. What we actually need is real data from real production with real users who have weird data, right? I have a 13-year-old Sprint account. They would really like me to upgrade. And I'm like, no, I'm fine, thanks. So they have to retain all of the settings for that account, even though they have moved on several times since then. When you have real production data, you're going to end up with that kind of weird edge case that you are never going to end up with in staging with created data. Or, God help you, with real data in staging, which means you have to secure it to the same level as production. You're doing that, right? Yeah? It's kind of hard to do. So where are my branches at? what are we doing? Nicole Forsgren and Gene Kim and Jez Humble wrote Accelerate. I didn't put up a picture of the book because we've already had a picture of the book. You really should read it, though. And you really, really only need to read the first third, which is, the second third is her doctoral dissertation. She's not fooling anybody. There's a lot of statistics. If you like statistics, if you're into that, you should totally read the second part. But the first part is basically, the faster you go, the safer you are. The smaller your delta, the faster you go, the safer you are. And here is the analogy that may not work for you all because you teach bike riding in a more humane manner. But in America, what we do is we put our adorable small children on a bicycle with pedals, and we say, okay, kid, go really fast and you won't fall over. And the kid looks at you like, this seems dumb. I'm going to fall and scrape myself, and it's going to be much worse than if I were going slowly. But you know, because you've learned to ride a bike yourself and because physics, that it's actually a fact that if they go faster, they're safer, to a certain degree. 45 kilometers, not the level we're looking for here. But they don't understand that speed equals safety. And what Nicole is telling us is that speed equals safety. If you can deploy 200 times a day, the odds of you having a breaking deploy are tiny. And you can roll it back or you can roll it forward because whatever you changed is very small. You're not doing this enormous rollout of all of the things. When you're doing release in this new era, it's going to be progressive and incremental. It used to be when we did a release, we shrink wrapped the discs and we sent them out, and then we had whiskey. That was how it went. It was before I started drinking. I was working in technology before I was 21. So I was like, do I get whiskey? They're like, no whiskey for you. And then I had whiskey, and I'm like, no whiskey for me. But we don't have this kind of enormous release. We have these tiny, incremental, progressive releases that make it much safer. The problem isn't habit when we're trying to change things. The problem is ritual. Like, Amazon says all teams should be 2 pizza teams, 8 people. I'm like, yeah, that doesn't work if you're distributed. Like, that's not a thing that works for me. Nobody buys me pizza. I work alone with a team on the other end of Slack. But people think that that's a model for how to do it. So there are 3 reasons that companies don't adopt new things when you're trying to make changes. Because now we have a standards problem. And nobody likes new standards because they're terrible and we have to buy new adapters. There's no business need to change. Like, they don't see any money in it. And let me tell you, no matter how altruistic you think your company is, they're in it for the money. They are in it for the money, and every argument you make has to be about money. And there's no perceived need to change. Henry Ford famously said that if he had asked people what they wanted, they would have said they wanted a better horse-drawn carriage. And he was like, no, you don't get what you want because you lack vision. I'm going to make you a horseless carriage. So how do you promote change? Well, you point out that the standards problem isn't getting any better, and it is now time to leave SOAP and move to REST, or if you're still on SOAP, just consider GraphQL so you don't have to have this argument again in 2 years. But we have to keep moving or else we'll get left behind and it will become harder and harder to operate. We have to talk about financial pain. This is the way that I get people to buy me software. I say, oh yeah, no, you don't have to buy me software, but it takes me, N number of hours to fight with Microsoft Word. At my hourly rate, that new software would pay for itself in 3 weeks. How do you feel about that? Oh, I can buy the software now. Excellent. And we have to talk about potential. We have to say, these are the things that we could do if we move forward, if we do something interesting. Here is a reason to do something other than fear. Because although we have scars, most of us have scars because we had aspirations, because we had dreams, because we, for instance, jumped out of a window onto what looked like fluffy snow, right? We're doing things that are adventurous. And if we can persuade the people that we work with that they want to be adventurous too, we can change hearts and minds. So, when you're trying to convince people to change, you need to stop pitching what you care about and look at what their problems are. What are they fighting with? What is their pain point? How could we make life better for them? Listen to what they are telling you about what they need to know. That's going to make it a lot more possible to persuade them. So, if this talk was too long and you checked out mentally and read Twitter instead, development, source control, and release methods are inextricably linked. When you change one, you change the rest. And you should consider what it is that you want to do and how your scars are holding you back or reminding you to be brave. And if you would like a t-shirt, you can take a picture of this slide and we will send it to you. I always love doing this because my fulfillment team is like, we're sending them where? So you should definitely make them send you t-shirts. Thank you all. If you have questions for me, I think I'm right up at the end of my time, but I'm pretty easy to find. And later this morning, I'm going to do an open space on DevOps and documentation, which is always interesting. Thank you.